Welcome everyone, myself Jayanth and I am currently pursuing my B in Sri Venkateshwara College of Engineering and I am studying in the third semester in the department Artificial Intelligence and the subject title is Mathematics-3 for Svce and the topic which we are going to discuss today is Joint Probability Distribution. Let's know what is joint probability distribution. A joint probability distribution describes the likelihood of different combinations of outcomes for two or more random variables. When dealing with multiple variables, a joint probability distribution shows how the probabilities are distributed over all possible values for those variables. For instance, if we are studying the relationship between rainfall and crop yield, the joint probability distribution can tell us the probability of getting both a specific amount of rainfall and a particular crop yield simultaneously. Joint probability distributions for discrete random variables. For discrete random variables, a joint probability distribution is often presented in a table format. Each cell in the table represents the probability of specific combination of outcomes for the random variables. Suppose we have two random variables x and y which represent whether it's rainy day and the number of hours people spend outdoors respectively. We could create a table showing the probability of each possible combination such as a rainy day with 2 hours spent outdoor or a sunny day with 5 hours outdoor. By summing the probabilities in each cell, the table must add up to 1 representing the certainty that some outcome for the set of possibilities will occur. Joint probability distribution for continuous random variables. When random variables are continuous, the joint probability distribution is described by a joint probability density function. For instance, let x and y represent height and weight. Unlike discrete distributions, where we can list every possible value, continuous distributions require to use integration to calculate probabilities or a range. The joint probability distribution function often represents as function that tells us the likelihood of x and y taking values in a particular range. To find the probability that height and weight fall within specific ranges, we would integrate the probability density function over those intervals. Third one is marginal probability. The marginal probability of a single variable in a joint distribution is found by summing or integrating over the other variables' values. If we have the joint distribution of age and income, the marginal probability of income is calculated by summing the joint probabilities over all possible age values, effectively marginalizing age out of the joint distribution. This gives us the overall probability distribution for income, regardless of age. For continuous variables, we calculate marginal probabilities by integrating over the range of other variables. The fourth one is conditional probability. Conditional probability in joint distribution describes the probability of one variable given that another variable has already occurred. In joint distribution, conditional probabilities allows us to understand the dependence between two variables. For instance, if you know that joint probability distribution of education level and income, we can calculate the probability that someone has high income given a specific level of education. Let's know some of the real life applications of joint probability distributions. Joint probability distributions are frequently used in marketing to understand customer behavior. For example, consider a retailer analyzing customer age and product preferences. A joint probability distribution can show how likely different age groups are to prefer specific products. This information is invaluable for targeted advertising since companies can focus their marketing efforts on the age groups mostly like to buy certain products. Real life applications in healthcare. In healthcare, joint probability distributions help analyze the relationship between risk factor and health outcomes. For example, researchers may look at the joint probability of smoking and exercise frequency to understand their combined effect on heart disease risk. By analyzing this data, healthcare providers can identify high risk groups and develop preventive strategies. Joint distributions can also aid in personalized medicines where treatment plans are tailored to individual patient profiles. Real life application of joint probability distribution in finance. In finance, joint probability distributions are used to assess portfolio risk. For example, A portfolio might include stocks and bonds, each with uncertain returns. A joint probability distribution of stocks and bond returns provides insights onto how these returns co-vary. If stocks and bonds returns are negatively correlated, the portfolio is diversified and may be less risk. By understanding joint distribution, investors can make informed decisions about asset allocation and risk management. The summary is joint probability distributions are powerful tools in statistics for analyzing relationship between random variables. They provide the probability of different outcome combinations and are foundational in fields like marketing, healthcare, and finance. Understanding joint distribution, calculating marginal and conditional probabilities, and determining independence are key for data analysis and decision making in complex scenarios. This was all about joint probability distribution. Thank you for watching the video.